Hello, and welcome to the solution for the first on-site interview question for the rideshare company mock interview. Let's go over the question statement one more time. So given a list of integers, find the largest product you can make from 3 integers in that list. And you can assume the list will always have at least 3 integers. So you have a solution notebook here available for you. And let's go ahead and discuss our strategy for the solution and then go ahead and code it out. First thing to note is that we can actually solve this problem in O(n) time with O(1) space. And we should also be able to take into account negative numbers so that a list like -5, -5, 1, and 3 is going to return 75 as its answer, since two negative numbers multiplied together will be a positive number. And then hopefully something that's really important for you to realize is that this question has a lot of similarity between other questions we've seen before, such as that Amazon stock problem from the e-commerce company mock interview. So again, you could brute force this problem just by checking every single combination, but that would be n to the power of 3 time. So that's really not good. So we're going to use a greedy approach and keep track of some of the numbers. So in the stock problem, if you remember, we kept track of the max profit so far, as well as the minimum price we've seen. So for this problem, we're actually going to keep track of several numbers. We're going to keep track of the following 5 numbers. We're going to keep track of the highest product of 3 numbers so far, the highest product of 2 numbers so far, and then just the highest number so far. And since we want to keep negative numbers into account, we're also going to keep track of the lowest product of 2 and the lowest number. So that will help us find answers like this: -5 times -5 equals 25. So once we iterate through that list and reach the end, we're going to have the highest possible product with 3 numbers. And at each iteration, we can take the current highest product of 3 and compare it to the current integer multiplied by the highest and lowest products of 2. So that's why we are keeping track of the highest products of 2, so we can multiply them by the current integer in that list as we move forward through that list. So let's go ahead and code this out. First thing we're going to do is start with our function. So we're going to say def solution. It's going to take in a list. We'll call it LST. And then what we're going to do is say a variable high, and this is going to be the highest number so far. So remember, we're keeping track of 5 variables. So the highest number so far, we're going to go ahead and start at index 2 at the 3rd element and assign the highest and lowest based off the first 2 elements. So when we're actually moving throughout the list, we start at index 2, which is the 3rd element. As far as the other numbers that we're going to keep track of, we'll use the first 2 elements to base those off of. So that means we're going to take the max of the first 2 elements, and then our lowest number is going to be the min of the first 2 elements there. And it's important to remember these built-in max and min functions. All right, so what's next? We also want to initiate the highest and lowest products of 2 numbers. So I'm going to make a variable called high_prod2, which is going to stand for the highest product of 2 numbers. And in this case, since we only have 2 numbers to start off with, we're just going to choose those 2. And we're also going to do the exact same thing for the lowest product of 2 numbers. It's going to be the first element multiplied by that second element. So the index 0 and index 1. And then we want to initiate the highest product of 3 numbers. So we want to say high_prod3, and that's going to be equal to the first 3 elements combined. Okay, so we have our 5 numbers that we're keeping track of. And we've started off with looking at the first 3 elements for the highest product of 3, and then the first 2 elements for the other numbers. So we have our highest number so far, our lowest number so far, the highest product of 2 numbers so far, lowest product of 2 numbers so far, and the highest product of 3 numbers so far. So now let's iterate through the list and see what we can do. Hopefully this is starting to feel really similar to that stock problem, just with more variables to keep track of. So we're going to iterate through our list, and we're going to start at index 2, that 3rd element. Let's go ahead and zoom in here so we can clearly see what's going on. Whoops. All right, so we're saying from the third element onwards, we're going to do a bunch of comparisons. First comparison we need to do is check if we have a new highest product of three numbers, the thing we're actually searching for. And so we're going to compare a couple things here. First, we're going to compare our highest product of three. So that makes sense. Compare our current highest product of three against a current number times the high product of 2, as well as the current number times the high product of 3. And just remember, I'm using tab here in my Jupyter Notebook to get those drop-down options. So as we go throughout this list, I'm taking the current number, multiplying it against the highest product of 2 so far, and whoops, this is actually incorrect. It should be the lowest product of 2. So let me restate that in case there's any confusion. So I want my highest product of 3 to be the max of our current highest product of 3 times the current number multiplied by the highest product of 2 times the current number times the lowest product of 2. Then I want to check for possible new highest products of 2 numbers. So I want to say high underscore product of 2 is equal to max. I'm going to compare it to the current highest product of 2, and then I'm going to compare it to the current number times num high versus the current number times low. And then we're going to do something similar for the lowest product of 2 numbers. In this case, we're searching for min. So again, compare it to the lowest product of 2 numbers, and then none times high, none times low. So that should get us the larger negative numbers there. And then we check for a new possible high. Max is that's just going to be high compared to the current number. And then low is just going to be minimum of low compared to the current number. Let's make sure that's touching its function here. And after all that, as we go through a list, we can just return the highest product of 3. Okay, so again, let's break down what we're actually doing here. Again, we're going to use a greedy approach on this problem and keep track of the numbers. So we're keeping track of several numbers. We're keeping track of the highest product of 3. And let's go ahead and zoom out so we see the whole picture. We're keeping track of the highest product of 3 numbers so far, the highest and lowest product of 2 numbers so far. We're also keeping track of the highest number and the lowest number we've seen, and then the highest product of 3 numbers. So what are we actually doing here? We're iterating through the list until we reach the end. And then at each iteration, we take the current highest product of 3 and compare it to the current integer multiplied by the highest and lowest products of 2 numbers. So let's do this step by step. We're going throughout the list, taking our current number, taking our current highest product of 3 numbers. Remember, ultimately that's going to be our output in the function. Taking that current number and multiplying it by the highest product of 2 numbers and the lowest product of 2 numbers. So that's going to allow us to take advantage here of a negative times a negative. Then we're going to check to see if we have new high product of 2 numbers and new low product of 2 numbers. And for those comparisons, we take our currents and then multiply our current numbers by the high and low numbers we have so far. Then we check if we have a new high and a new low, and then we would just return the highest product of 3 numbers. So this greedy approach allows us to do this in O(n) time. So you should always keep this sort of approach in mind when you have to iterate through a list, and you can see that clearly there's a brute force solution, but it's on the order of an exponential. So this should be really reminiscent of that stock problem. So again, for this problem, we're just taking track of everything as we go throughout the list. The trick to this problem is realizing that you had to keep track of these highest product of 2 and the lowest product of 2. So go throughout the solution, make sure you understand it, add print statements as needed for you to fully understand this problem. But just remember, we're just keeping track of a greedy approach to this problem, keeping track of certain variables, in this case 5 of them, in order to find the highest product of 3 numbers. Again, you can always read out the full explanation in the solution notebook. All right, Well, that's it for this solution. I'll see you at the next lecture. Thanks, everyone.